These are our notes on section 3.5, polygons and their angles. A polygon is a closed figure whose sides are all segments. Some polygons you know of are squares and triangles. These are all closed figures where their sides are all segments. Over here you can see a convex polygon and what it looks like. And here you can see a concave polygon. Notice that they are both closed. On page 158 in your textbook, it lists all the different names of polygons. Examples would be a triangle that has 3 sides, square that has 4 sides, but in your book it lists some of the polygons that are not maybe so familiar, like an octagon with 8 sides, or a decagon with 10 sides. So if it's referring to a polygon and you're not sure how many sides it has, you can refer to your book on page 158. These are the 2 theorems that we will be working with this section. Interior angles is the sum of all the interior angles of a polygon. So this is the formula you can use to figure out the interior angle of a polygon, since it varies depending on the number of sides of the polygon. So we have 180 times n minus 2. N always represents the number of sides that the polygon has. And as I stated before, if you're not sure of that, you can reference page 158. Exterior angles all have to add up to 360, no matter what kind of polygon it is. So the sum of all exterior angles is 360. Here are a couple of examples. For the first one, it's asking what is the sum of the angles in a decagon. So since it is asking for the sum, we are going to use the first theorem, which is the 180 times n minus 2. It's asking for a decagon, so a decagon has 10 sides. If you didn't know that a decagon had 10 sides, you could look it up on page 158. So again, we know that the decagon has 10 sides, but however many sides your polygon has, you would take that number and plug it in for the n. So in our case, since we know we have 10 sides, we would take 180 times 10 minus 2. And so we would have 180 times 8, because 10 minus 2 is 8. And that would equal 1,440 degrees. And that is the sum of our interior angles. So we know that the sum of our angles in a decagon would be 1,440 degrees. But we could also have an example like this. In this example, we're supposed to solve for x and all the angles in this polygon. When we did triangles, we knew that there was 180 degrees in every triangle, so we would just add up all the angles and set it equal to 180. Well, in this picture here, we are going to add up all of these, but we don't know what to set it equal to yet because we don't know how many degrees are on the inside of this figure. So the first thing we need to do is figure out how many sides it has. So if I count these, I've got 1, 2, 3, 4, 5, 6 sides. So after you know how many sides you have, you go back to the formula and plug in how many sides. So if we use our original equation of 180 6 minus 2, because 6 is my number of sides, then I really have 180 times 4, which would equal 720 degrees. So, inside this polygon, I know that I can add up all these angles and it will be set equal to 720. So if we do that, you're just going to write all of them down. So 10x plus 13x plus 30 plus 160 plus 8x plus 100 plus 8x plus 40 equals 720. And now you're going to solve for this big long equation. So when we combine like terms, we get 39x plus 330 equals 720. So then I'm just going to subtract my 330 from each side. And you should end up with 39x equals 390. So if I divide my 39 off, we would get that x equals 10. So if x equals 10, now we can go back and we can plug that 10 in for these x's. So we know for this one, we could say that if we plug in the 10, I know that this one is going to equal 100 for that angle. And you could go through each one and plug it back in. You know that this one's going to equal 80. And we could figure out the measurement for each angle for those by plugging that 10 back in for each x. The definition here is for a regular polygon. Regular is the key word here. Whenever you see regular, it means that all the sides and angles are congruent. So the length of every side is exactly the same. So I can mark it like this. Can mark each side, 1, 2, 3, 4, 5, 6. And I know that all of those sides are equal. They're exactly the same. And the angles on the inside are exactly the same, so I can mark them like this, showing that each angle is congruent. So anytime you see that the polygon is marked regular, you should go ahead and mark these so that you will know and you'll remember that they're congruent. When you solve for the interior and exterior angles, you can be more specific because you know that all angles are congruent. In this picture, right here, if we count the sides like we did, 1, 2, 3, 4, 5, 6, we know that it has 6 sides. So since it is a regular hexagon, if I want to figure out the interior angle, I'm still going to plug in my sides for n. So I can still write right over here, I can still put 180 times 6 minus 2, and then subtract the 2, so I know that I'm going to end up with 4. I'm also going to be able to divide by 6, so I'm going to write that down here. And the reason I can do this is because all angles on the inside are congruent. So it would look like this. So we could write 180 times 4 divided by 6, and we know that that would equal 120. Now for the exterior angles, remember that on the first screen, I said that every polygon has an exterior sum of 360. So since this is a regular polygon, all of the exterior angles are congruent. So inside the polygon, we can take 360 and divide it by 6. Since we had 6 sides, and that equals 60. So we know that all of our exterior angles are 60 degrees. And if we were to draw our exterior angles on here, remember that they come off the side. So right here would be one of our exterior angles, and that would be 60 degrees. And here would be another exterior angle, and that would also be 60 degrees. All right, here's a couple more examples for you to test out on your own. First one, find the measure of the interior and exterior angles of a regular pentagon. So we need to find out how many sides a pentagon has. And then find the measure of each of the angles in the n-gon below. So we need to figure out how many sides it has, and then do those calculations. So I'm going to pause the video now so you'll have time to figure that out. Try both examples. Here are my calculations for each one. Hopefully you found the same results when you did your calculations. For our interior angle, it was 108. Exterior angles would be 72. And then to figure out the measure of each angle in this n-gon below, we had to count up the sides. We found out hopefully that there were 7. So that's how I calculated, used my first theorem to find out the internal sum of each angle of the angles, and then I had to calculate out for each angle so that we could figure out what we would have for x, and then once we solve for x, we can plug that back in, and then we can find the measurement for each of our angles.